Thank you guys so much for coming out today. We are very excited to be walking you through using Azure Databricks for machine learning, using some different use cases. So not going to see some of your traditional business use cases, but we hope that'll make it interesting in our demos.
So my name is Diana Phillips. I'm a cloud solution architect at Microsoft in the US One Commercial Partner Organization. I work in the data and AI swarm and specialize in the Internet of Things area, so I help partners with their IoT solutions.
And my name is Laura Dell. I planned to play a rap battle for you between Alexa, Cortana, and Siri to do my introduction, but due to copyright issues, we couldn't do that. So I'll just put it out there that the reason why I chose that rap battle is because I worked at all three. So there's my quick background to who I am as an intro. I am a senior data scientist at Microsoft for our national organization.
So we're going to start out with a quick survey so we can understand who's in the room. This is an advanced Databricks session, but just to understand who is new to Databricks, let's have you all stand up.
Trust me, it's worth it. We have really good swag. Oh, see, I see. So participate. So those of you who have never used Databricks for machine learning, please sit down. Awesome. That literally, I don't know if we need all three. Those of you who know what the Spark, or don't know what the Spark 3 APIs are, Spark's 3 APIs. Is that everybody? No, I think there's one.
There are two.
There are two, okay. Those of you who haven't attended a previous Databricks session, sit down. Nice. All right, you're presenting. Come on. Now we got two of you. You're me, and you're him.
There are two of them.
We're just
standing.
Yeah, we're just kidding. So that gives us a really good framework for.
Do we want to give him swag?
Yeah, of course, of course. We're not exclusionary by any means.
All right, so we're giving you the MX Chip IoT Dev Kit so you can connect physical telemetry with your solution.
So now you guys see when we ask you to participate. Hint, hint. Yeah, you're welcome.
All right, so continuing on.
So really quickly, we know that this is all about what's in it for you, which is why even though there's a bunch of slides you see, oh, you don't see the slide number, so that's good. We're going to make those part quick so we can get to the demonstrations because we realize that's what you care about. So we hope by the time you leave here today, you'll know what Databricks is. If we failed on the what of this, then we failed altogether. Hopefully, you'll know when to use Databricks for machine learning and where, in terms of our GitHub repo, we've put forth a ton of code, example notebooks, Databricks archives, so that you have that information. And then lastly, if you're paying attention, the why you use Databricks. There's probably quizzes around that. And then the last part is, as I mentioned, all the code. We're going to assign it as homework in light of it being a 1-hour session, but we've put challenges together that have labs that walk you through what to do to build out these notebooks, and we hope that you'll do them in your own time. They can be repurposed, again, within your customers quite easily, and we explain how to do that.
All right, so the way that the session's going to work today, there's so much to cover when we talk about machine learning and Azure Databricks, so there's way more than we can possibly cover in this session. So what we're going to do is divide our presentation into 3 parts. So for those of you that are new with Azure Databricks, we're going to do an overview with a quick cram course on what Azure Databricks is and the ML functionality within it, just so everyone's kind of on the same playing field. Then we're going to review 3 different use cases that we have around machine learning in Azure Databricks. And then we'll finish up with the homework and kind of give you an overview of what we have within the labs and the link to GitHub so that you can go with that as a takeaway and do that on your own so you can really get your hands dirty and start to understand some of those capabilities that we're going to talk about today.
All right, so we're going to jump through our very quick course of machine learning and Azure Databricks and what it is. So I guess really quickly, how many of you know what Spark is? Okay, good. Excellent. So we really don't need to go through a lot of this because you know what it is. But Databricks provides you an abstraction on top of it that unifies a lot of those lower level libraries and processes and APIs within Spark. So a lot of what we're covering today is going to focus on that machine and deep learning, those APIs. But all of these are supported within Azure Databricks.
So within Azure Databricks, we have a unified landscape, and this slide shows the different areas based on your role, their capabilities that would apply to you. And when we look at all of the functionality here, it's a notebook-driven development environment, and you can access data, you can do different API and library functionality, and it does use the Spark runtime. Is there anything you'd like to add here?
So, I would just add that a lot of people think about Databricks more in a pre-processing data engineering environment, because you can do a lot with it. You can do a lot of that ETL transformation. You can then pass it through and load it to other services in the cloud or on-premise. So a lot of people are using Databricks on that true, pure data engineering aspect. I, as a data scientist, come at it slightly differently. I use it for pretty much my end-to-end modeling needs, because as anybody knows who is in the machine learning space, if there's any, there's a huge component of what we do that is data pre-processing for the benefit or the worst of it. And so this platform enables you to have that end-to-end experience, as well as then be able to deploy it with other services that are supported, so that you can start with data ingestion, cleansing that data, doing stuff with it, passing it off and storing it in other areas. Maybe you're storing it in a blob store somewhere, S3 in Azure. You're storing it somewhere. Maybe you're then storing it more relationally in a database or a data warehouse once you get your canonical structure. And then you have, where it passes off into that data scientist landscape. And so that really enables you to have your data engineers and your scientists work together. And then when you come to deploy, it really then brings in the DevOps folks to then help them understand, what it is you're deploying, what are these libraries that they have to package up or jar files, what are they doing, and what's the security look like overall. And so that's what the platform really enables you to do quite easily.
So Azure Databricks is within your Azure portal, and so it plays nicely with other services that we have within Azure. First of all, you can provision the service or launch it directly from the Azure portal. You can actually access your storage in blob storage or Azure Data Lake Store. It uses the Azure Active Directory security, so you don't have to maintain separate sets of users in Databricks and Azure. You can also combine both structured and unstructured data for your analytics. And you can leverage Kafka for streaming data, either as a source or a sink. The Azure billing is where you would be billed for your service usage, and then you can also integrate with Power BI. So speaking of the unified platform, we do have great performance within Azure Databricks. So it's actually much faster than just using Hadoop. And in some of the tests, it can be up to 10 times faster. And that's because everything is managed within the memory, and so it's very, very fast. We also have developer productivity by allowing you to combine different syntaxes. You can have Python or Scala or SQL just within one notebook and kind of switch back and forth. There are also APIs and libraries that allow you to do some functionality without writing it from scratch.
And you'll notice that the Databricks delta there in the middle. So I think there was a big gap for a while with Databricks in terms of Spark in general when it came to SDC, so slowly changing dimensions, or the change data capture that would happen. So you'd have to basically read an entire sets of these Parquet tiny files, string them together, which was very inefficient. And what Databricks Delta now allows you to do is to have just what is the diff being read. And so that gets partitioned off into its own table so that you can then join it back in with here's our original data set, here's our new data. And if you think about this from a streaming perspective, where maybe you're streaming for fraud transactions, maybe it's gaming streaming, whatever that might be, this then enables you to have a much more real-time stream ingestion process when we're talking about big data pipelines. And so, I'm gonna hint. Let's pay attention here. The thing in a swag. So, this is just a really quick history. Since most of you know Spark, I'm not going to go into a lot of this, but in terms of supporting an abstraction layer, the RDD is really the core. It was the primary, user-facing API since its inception. But as you know, RDD is immutable. It's only good for lower-level, well, I shouldn't say only. It's good for a lot of things, but lower-level transactions. Maybe you have unstructured data. Maybe you want to manipulate and use other functional programming constructs. Maybe you don't care about imposing a schema. There's a whole host of things of why RDD is still important. But as time went on, and as these migrated to where we are with the data set API, which is nearer to where we are today, A lot of those optimization issues and performance challenges are foregone with using the newer dataset API. So I would say that it is not good from a data scientist perspective, but it really gives you that best of both worlds that you see from the other two API types. Oh, I have the thing.
That's another slide.
And so this is what it looks like bringing it together. And so this is really going to be the crux of what we're focusing on today. And so it's using what is called Spark ML, so Spark for machine learning, which really enables you to get that benefit of Spark, so that parallel distributed machine learning across large data sets. And that's huge when we're talking about machine learning. You're not having to do a lot of that feature selection or arbitrary, let me limit down my columns that I have because my data set is too big to be able to process in memory. This allows you to distribute that and parallelize it across your algorithms, which for the types of algorithms we're going to be showing you is very important. These are the types of supported algorithms today, just in Spark in general, and of course then are supported on Azure. We're going to be focusing a lot in the regression piece as we go through NCAA March Madness and how you can use Spark to help you better forecast. And then a bit on the clustering to give you a semi-supervised, unsupervised flavor of Spark, and then touch on a really interesting deep learning use case. So it'll really give you 3 flavors of machine learning. More the traditional supervised learning. You've got some labels. You know what the labels are for your data. Let's go ahead and label it. Using that to do a forecast. Then using more of the clustering where you don't really know your data. Maybe you're given some foreign fruit and someone says label these and you're like, I don't know what I'm looking at. But you know that the color is yellow. You know that it feels very spiky. So those become things you can cluster or group things by. So we're going to go through what that looks like in terms of Spark. And then lastly, on the deep learning side, using sound and noise signaling. And then, of course, Spark R is now supported, but I'm a Python person, so if you're a big R person, there's some slides in here for you. No, so I mean, it's important to support everybody's, as they said, code base. So if you're coming at this from a Python, then you're going to fit right in nicely. If you're coming at it from an R background, because you are coming out with very strong statistical background, it's what they teach you in school probably, it's what I learned, then having the support for R is very important. It gives you the ability to distribute it, and then there's packages like Sparkly R that allow you to parallelize it, but there's some limitations and gotchas in there that we have in the appendix. And then, of course, deep learning. Well, we're not going into a lot of depth on what these different things are, but basically this is your ability to look at things like images and do image recognition. In our sample, we're doing sound or audio recognition. But again, in the appendix, we have a lot of information for you there to walk you through. All right, so let's get to the interesting stuff. So who here is a sports fanatic? If you all say you're not, I'm going to be like, okay, well, I'm going to make you one by the end of this. So
a handful.
I knew nothing about any sports when I started this journey 7 years ago with fantasy football, and it was all because my father-in-law said I couldn't use statistics to do it. And I was like, okay, gauntlet's thrown. In the year 1 I tried it, I failed, because it was training, and he was like, I told you. But by year 2 to now 7, predicting the outcomes of a fantasy football model have won me my league every single time. Now, granted, it's the war I'm looking to win. There are battles lost in weekly matchups. That's a given. This is not 100% perfect science, or Warren Buffett would have given me his many millions of dollars he said if you can solve March Madness. So after perfecting fantasy football, I went down the path with basketball. So here's a really quick pop quiz here and see how many of you are, since none of you are football fans, I don't know if you'll know this, but do you know what the odds are of getting every bracket correct? So predicting every game correctly, the 63 games that occur in March Madness. If you're a math person, you might be able to think about what this is. Oh my gosh, you got it! I was not expecting anybody to get that. So, nice. Come on up. No, I'm not joking. Come on. Ooh. This is an MX. You don't have to take it, but it's an IoT device. And it's like a Raspberry Pi, but here you go. There you go. You're welcome. If you want to give it back, you can. I want one. All right. So, all right. So we were not expecting that. So that's excellent. All right, so in terms of the way this was approached, so I do this a little differently. I take data, and in my pre-processing, and I go through an extensive classification just to understand, obviously, the data that I don't know. And this was really important in order to create this training set, because passing in stuff around seasonality and how you did in one season versus, say, a team and how they've done in many seasons was a big decision point as we were choosing, or as I was choosing feature selection. And so ultimately, and the crux of what I was trying to do here is predict, is this the, no, all right, is given, two teams, this is a winner-take-all, meaning if you do not win that particular game, you're out. So this is a winner-take-all model, and so let's come up with a probability that that team's going to win, given many factors. So there are things like, is this team hot? What is the strength of schedule, which is what SOS is. Things like the location. There's a thing called home court advantage. And so as you can see from, this is the actual feature selection set, it makes sense that wins would be on top because, if you're winning in a season, there is a strong likelihood you will win in your brackets, when you're competing against another team. That makes sense. Strength of schedule, it made sense to me from a fantasy football perspective because, if you're playing against the easiest teams or if you're playing against the teams that are weakest, which is what happens in March Madness, you have the strongest teams playing the weakest teams in the beginning, which is curious to me, but that's how you get these massive upsets, like what happened with Duke. And then, the rest made sense. So from a gut perspective and not knowing anything about basketball, this seemed to make sense to me, and so I had somebody that I work with validate it. And so taking all of this information in, you have to vectorize it. Your X inputs are going to be, this is the supervised learning problem. We have a set of labels that I know, who's the team, who's the players. All of that information becomes my feature sets, and then I also know whether or not they won. So I can give them, a scoring value for win or loss, and that becomes my label. And so I also then wanted to take this approach of what I call the sort of secret sauce, and that is scraping social data to come up with a player index. And so, I had a theory or a hypothesis that on game day play, if you've just had a baby, if you've just been arrested, whatever the events are that occur in the social space, that's going to play with your brain. I mean, it would play with my brain, especially if you had a baby and were arrested on the same day. It might not play as well as you would like, and it turns out that that's very true. So those things, keep you up at night, affect your game day play. So I created a weighting, which was that player index, to then take all these values, in addition to what is the ELO score. So does anybody know what ELO is, just in general, from chess, from gameplay, if you're a gamer? Okay, no. So ELO is just a simple way that you can rank the relative skill of players in a zero-sum game, which is what we're talking about here. And so, the ranking, and I'm sure you've heard of Nate Silver and his projections on election, come from, ELO comes from, a rating that he's come up with on the bracket, and it basically takes the final score of the game, factors in things like home court advantage, is it a regular season, is it the off season, and, it comes up with a rank. But that's pretty simple. You need to do things like then take into account winning games and losing margin, because if you win by a ton, and that win is a super, no one expected it, it should be weighted differently than just a win if you're expected to win. But those upsets that really change the brackets needed to be weighted differently. And these are sort of all the gotchas I learned as I was going through this in Databricks, and we'll get there into the notebook in a second. So as I was going through also, a lot of the pre-processing and looking at data, it's always very important to look at how normal the data set is. The good thing is about all the publicly available sports data is that there's a lot of it. There's a lot, and it goes back many, many years. I think I have 20 years of data supporting this. And so you can see here, just different ways in which I was slicing this, looking at, teams by year, performance by year, gameplay by year, rank by year, to come up with what was the most normal set of data that I could use to then predict out probability. And so this was a tidbit my friend gave me, but none of you are sports fans, so maybe you won't know it, but essentially, in the 2014-15 season, the Toronto Raptors were rated very, very highly, and they were expected to win. The Cleveland Cavaliers were rated very low, and they were expected to lose. So they had, their average ELO ranking as expected. But as you can imagine, the opposite happened, and so Cavaliers needed to be rated higher or ranked higher in order to accommodate that upset. And so in terms of then the result for this year, and I'll show you this in the notebook in a second. So Virginia won, if you know. But this was the end bracket. It's about 89% or 86% accurate, which you can see here. And so you can see the series of models that I ran through in Databricks, and you can see that I came up with that which scored the highest in terms of its probability accuracy, as well as the lowest root mean squared error. And so that is how I determined, what I wanted to base my bracket projections on. And so I will now switch over and just show you how to instantiate this in Databricks. All right, so this is the Azure Databricks environment. And so what you see here is a lot of different libraries that you can bring in. I'm using a cluster type that has a lot already installed for you, so it made getting off the ground very fast in terms of, for those of you who've not used Azure Databricks, coming into here from a first time, creating my cluster of whatever size I want it to be in terms of how many nodes I want, how big do I want it to be, what kind of Databricks driver, the Spark driver that I want to use and version. And then just start importing or bringing in notebooks, building them from scratch. And so that's what you see here. And the end result is a set of a lot of historical data. And the net result at the bottom, though, is as you run through this, and all of this, by the way, code is available for you, so you have these notebooks in my GitHub. All of that's in the presentation. But I created a bunch of functions that enable me to make it a little bit easier so that when I want to call on games lost, when I want to call on number of games, or these things that take into account ELO ranking, I can just call them as a function and apply whatever the different values for that year and that player I want to apply are. Made it a lot simpler. And then just to test out I do a lot of validation and cross-train and evaluating of the model, and then this is where the numbers that supply that are in here. So you can see, again, this was the final bracket, final four, and the last projections that came through. Again, it's still projected Virginia. And so that was an example of supervised learning, where I knew the labels, I applied it to a set of data, I had that then run through the model in Databricks, and as it turns out, using what is a boosted decision tree, which is really an ensemble of other algorithms joined together, had the highest evaluation metrics at the end. And so again, when you want to bring this into your world, or if you want to play around, there is a free version of Databricks that you can sign up for. It gives you whatever the time frame is to use it. There's no limits. All you'll do to bring in the notebooks that we've provided is come here and select import. And that'll allow you to bring in any of the Databricks archive or notebooks that we've provided for you. What? So I have out in my GitHub, when you go get this, there is a called DevOps for Databricks, a whole library there that basically takes Azure DevOps, or what was VSTS, and walks you through the end-to-end pipeline of taking this then and putting it into a DevOps pipeline. So it is a separate from this content, but it is there.
Here's the evaluation. Did you already do that one?
Yep.
All right, so for our next real-world scenario, we have a movie recommender. So this is a common scenario that you'll see where people want to understand and predict what people might want to do or see. So let me give you some other examples. So we have movies, but we also have books or recipes or furniture or things on Pinterest that you might like.
Or games you play on Xbox. I mean, anytime you see recommended for you, it's based on a recommender behind the scenes that's taking your profile, who you are, the things you like, and coming up with what you want to see.
Yes, so for this scenario, we're doing movies specifically, but based on the ratings of the movies that you've previously reviewed and then the ratings of others, it's going to recommend specific movies that you might also want to see. And so in this specific case, for this model, we're going to be using the alternating least squares algorithm, which is a collaborative filtering model that takes exactly what we're talking about, the ratings that you're giving and the ratings that others have already given. And so to talk through this a little bit, first we need to understand the data that we have available. And so this is a data set that's open and publicly available, and I'm not going to do a live demo on it because it's actually something that's in your homework. So if you're interested in the movie recommender, that's going to be in homework lab number 4. But you're basically going through and you have a movies table. There's a CSV actually in the GitHub. Has 9,125 movies. This is a sample of what the data within there looks like. And then it also has a users table that contains both the user ID, but also the movie ID and the ratings. And so this is used for the model. And this has over 100,000, just barely, user ratings. So the algorithm, when you go through the model, you join these together when you're preparing the data, and you get a very sparse matrix. And this is what the algorithm is going to use. So in building the actual model, this is using the SparkML library. And we're going to import the ALS class for that alternating least squares, which is our collaborative filtering. And so I've included some of the code snippets here for your reference, if you want to just reference the slides and not go to the actual notebook that's in the lab. But when we load and prepare the data, we're going to load both of those CSVs, we're going to join them together, and we're going to change some of the names of the different columns to kind of prepare the data for the model. And then we're going to build the recommender. So this is just an export from the notebook on what the command would be to build that recommender. We're going to split the data, and then we're going to train it. And then at the end, we're going to test our results. So before we get to the pop quiz, let's just switch over. In addition to the work that we're doing in the model itself that's in the notebook in the lab, we have a visualization that we've put together that kind of goes through these movie recommendations.
So essentially, it's doing exactly what Diana just said, but it's allowing you to find out for movies that I like. So this, I'm not looking for Ghost. Ghost. Or I will just use Ghostbusters. You can see here other movies that are nearest in the point of interest, meaning people that like Ghostbusters have a, if we were to cluster them into a category, recommending to them Speed as the next movie they might want to watch is a great way to capture the stickiness of that person. You can think of this, if this was a grocery cart and they were shopping, this is a great way to recommend to them, I see you've bought cheese, maybe you want to buy this pizza dough. I just went through doing that. So, and so you can see here that as drilling into this visualization, it allows you in a three-dimensional space to really get a good understanding of what those movies are. I think it's curious that Ghostbusters and Full Metal Jacket are in the same bracket, but anyways, you can then go to and scroll through to see out which ones are the closest. So I can see here those in red are those that are not very, very receptive. So if anybody's seen Blue Valentine, that is a very long and sad, depressing movie. And if I'm looking to laugh in Ghostbusters, I'm definitely not looking for that. So this is just a great way to visualize this. This is called a tensor board. Tensor board is part of TensorFlow's libraries to allow you to visualize any of these algorithms that we're showing you. We have a ton of samples in that GitHub, and this is just one of them.
All right, so now we have a quick pop quiz. So raise your hand high if you recall what collaborative filtering algorithm we used.
And you got to say it loud. So what collaborative filtering algorithm did we use? ALS, yes, that's good. Come on up. Woo, yay, what a prize. I know it's not easy to talk at these things. Believe me, it's harder to solicit it, so that's why we're trying to bribe you.
All right, so now we're on to scenario 3.
Will you flip over?
Oh, yep, let's go back.
So this is the deep learning scenario I mentioned previously. And so first I'm going to give you some background, but I want you to listen to these two sounds, and if you can tell me what differentiates them just by ear. And then the second one. All right. Do you have any ideas? I had crazy things being thrown at me at a conference. Yeah. Very good. That's not the right answer, but that is actually where I'm going to next, so that is a really good answer.
Do you want to give one of these things?
Do you want to come up for some stuff? Or you can come up after if you want. Woohoo, good job, thanks. All right, so no, the difference is the first one is my son making a sound on his arm. So he was a good participant. So the second one is an HVAC fan that is getting ready to have an issue. So it's working in okay condition, but in looking at the waves of sound and the amplitude, it was starting to spike, so it was throwing some anomalies. And why that's important, I think that we already aforementioned, is when we're talking about noise in general, in the sound space, just in case you missed it, there's a lot of things to take into account. There's vibratory patterns. There's the medium it's being passed through. So if you're looking at an HVAC that's on a roof, you're going to have a very different experience than an HVAC that's in a house. Unless you're like have my HVAC, which is incredibly loud. I need to imply this in my own life. But then you also have things like exactly how loud it is. That's part of what helped us here. Looking at how many bits are thrown per second, so that's quantization. And then looking at frequency versus time resolution. How quickly is it happening? How frequently is it happening? And all of this, when put together, enables you to then determine what is an anomaly versus an expected sound. So this project was a customer that came saying, you know, they had a dream of body cams, but they had technicians that were brand new and some technicians that had 30 years of experience. And they wanted to be able to take those body cams and have the cams zone in on the part of the HVAC that they were looking at, automatically deduce what the part is, pull up any guides that go along with the part. So from a maintenance perspective, that technician now seems fully informed whether they're 30 years in and have, you know, domain expertise or they're brand new. But then on top of that, you know, if we're talking about mixed media, why not listen to the sounds that these things are throwing? So I know that there's a car company that's now doing the same thing, so that when I go to get my car maintenance, I'm not trying to make my car's making a tick, 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 tick sound. Well, it would be even worse if I'm trying to explain my air conditioner to somebody. And so that's really what you see here is the ability to take a listen to what are expected sounds in terms of that feature vector and what are, you know, anomalistic sounds. And then can we group these to be able to classify them and then later use them to predict out what exactly is happening and then tie it into that image recognition. Here's the part. Here's what the expected part should function like. And this, of course, isn't going to be for every part. This is for parts that make sounds. So don't you think, well, if it's a valve, you know, it's not like, you know, it's for things like the fan or other components that are connected into the module board. So there was some semi-supervised learning here in terms of being able to label those things. Now, you can see here in terms of all of the different features that are potential as we were going through this, there's a lot of discrimination that needs to occur. When you're talking about text, and some of them, you know, didn't have the body cams. These were, you know, it was a test. Some of them had their phones, so some made very long feature recordings. Some made very short ones. There was a lot of talking as they were talking to the customer over the sounds. You know, this wasn't a great sample in terms of testing, but it was perfect for real world because that's what happens in the real world. And so we had to be able to take out and segment those sound effects to be able to look at that. So we did things like identify if it was a human's voice, and to subtract that out. We looked at silence, because the silence that occurs in between is just as important as the activity or the sound that's going on. And then looked at, you know, what was the shortest range of homogeneous content we needed to be able to deduce this. So you can see here, this is, you know, the confusion matrix at the end of being able to analyze this, but this is of all of the different sounds that are out there, and I know it's really hard to see. But when you get into the actual notebooks themselves, which I'll show you quickly, we were at an overall, at least performance rating of the model's ability to assign it correctly roughly 90% of the time. That's great. But I more care about all of the ones it didn't get correct. And so it's very funny to see where it miscategorized them in that you know, if we were zoomed in here and you could see that one of them was an airplane. I could see that. One of them was a monkey. And I was like, I don't know about a monkey. But that just told us more than what we need to train it on these different sound effects and how we needed to then go through and scrub some of the data sets that we had. So before we get to the quiz quickly, just to show you the notebook, so you know when you're going through this. All right, so this is, again, this was our deep learning example here and how we did this. So we were looking at what's called a DNN, that is a type of algorithm or the type of neural network that was used for this model type. And it allowed us to basically take the sound domain and spread it out across a lot of layers without doing a lot of pre-processing or featureization up front. And so as you go through this, you'll see that there's a lot of code here to validate it, but in the end, what the model result will tell you is you can feed it in a whole host of sounds and then have it tell you exactly where it classifies it into that confusion matrix. So basically, there's 4 million different sound effects in the training library that I have, the corpus. So you can use that. And if you wanted to augment it with your own sounds just for fun, or maybe you do work in a place where there are predictive maintenance, machinery type events, you can just go ahead and what's called transfer learn and actively learn them into the model by taking the existing training set that I provided for you in GitHub and then just augmenting it with the sounds that you have, like I did with my son's sound effect. And so is one of our last pop quizzes here. So I've given you some examples of deep learning in terms of image recognition to determine the part. I've given you some on the audio spectrum, so signal-based. Anybody have any other deep learning examples that you've heard or thought of, maybe in verticals that you could apply something like this? Time series data is a very good one, and what specifically? Excellent. So yeah, a lot of the text-based, unstructured that you hear about, video, imaging, a lot of that you see on, well, you don't watch sports today. A lot of what you see on TV today, a lot of what you read on the internet, those articles aren't written by people. Those articles on blogs are written by machine learning that's doing deep learning behind the scenes because it's piecing together pieces of information and text corpus to come up with that story, which is why sometimes you'll see little blurbs in the middle that make no sense.
All right, so now we're moving on to part C, which is the homework for you for hands-on learning. So we have 5 different sections within this GitHub lab. And so lab 1 is actually your setup. It's going to go through and help you provision Azure Databricks, help you set up the storage, and import some airline information that you're going to use for the first labs following that. So after you set up the data, then it has 2 different labs here. Lab number 2 is building a supervised learning model. And lab number 3 is going through and building on that. There's actually a different scenario. I believe they're both airline scenarios. Mm-hmm. So it's when the flights are going to be late, kind of predicting things around that.
Predicting if they're going to be on time, yes or no, and then how late are they going to be.
So then we move to lab 4. This is the recommender, and this is actually based on some movie data. So if you wanted to learn more and do it yourself, this is the one to go check out. And then lab 5 gets into the deep learning side.
And for this example, we've given you a retail example on being able to pick out clothing items based off of features that maybe you like. So like clothing that you may want.
So to get started with this homework, you'll want to go out to the GitHub location that this link will redirect you to. So we created this workshop just for the build session attendees, and you can go out here. Within there are several files, and you'll want to run lab 1 for the setup, like I mentioned. And this is kind of laid out like a recipe, so that will preheat your Azure Databricks environment. Then you'll make sure you download all the files so that you have your data files, the lab instructions, and your corresponding Python notebooks. What's the other one? Scala?
It's been provided for you in Scala, which is native to Spark, as well as in the Python wrapped libraries.
So you can go through, take a look at the different models that are out there, and follow the specific instructions for each of those. And so for takeaways from this session.
So hopefully we've talked to you about what Databricks is, given you a little flavor of it. We've shown you or talked to you about how you can use Databricks for some modeling types. We've definitely provided a ton after the fact where to go and when to use it. And then lastly, I can tell you from a personal experience being at Microsoft, having never used a PC prior to being hired 10 years ago, 3 years ago, 10 years, that in my blog 10 years ago, I had nothing nice to say. So in my interview, I was like, full disclosure, this is what I said. But coming from a person that was, I worked at Amazon, as I said, I worked at Apple on Siri Generation 1. Don't judge. If you remember your first iPhone, Siri Gen 1 was cool. Okay, I'm looking at all of you because I know you're thinking Siri right now. But this gave me a really good understanding of when I came over here, why my opinion 10 years ago was so different now. And I think Databricks is one of those ones, as a data scientist who lives and breathes this every day, I really hope that the content that we've provided for you will give you a jump start to be able to use this. If you ever have any questions, my email is on my GitHub. If you flip over quickly, if you go out to, it's in the deck as well.
Oh.
But
where was it? Oh,
flip over to here.
Got it.
Yeah. So if you go out to GitHub and then Android, I've got the sound libraries. I've also got March Madness. I've got my fantasy football. I've got some stuff I'm working on for the Kentucky Derby by request. I've got the DevOps for Databricks to the question that was asked earlier. So there's a lot of different examples that are out there. And if you ever get stuck or have a question, and I'm not just saying this because I want a high evaluation score, reach out to me. I end up collaborating with a lot of folks via GitHub, and so I would more than willing to help you debug or figure out how to apply it to your environment.
All right, and then we'd like to finish up with some resources to help you continue your studies here. So the first link is the Azure Databricks documentation. Really good resource for all different types of examples for just setting up Databricks and the different capabilities within Databricks, including the machine learning capabilities that we've talked about today. We also have a blog that you can read to get kind of an understanding of Azure Databricks if you're new to it. And then I've included a couple links here where you can find publicly available data sets to do some of your models on. And when you go out here, they both have a wide variety of very large data sets, so you can play around with those. And then the very last link here is, again, our lab cookbook that's out on GitHub.
And if you'll just flip over, I'll just walk you through what we were talking about so you know what we're saying here. So in terms of the cookbook, this is where it will resolve you to. So you can see here that it's broken out so you know exactly what type of model you're trying to walk through. But all of the steps, as we said, of how you would build this yourself for those that are new to Databricks, new to Spark, and writing out, again, it's provided for you in Python and in Scala. But all of the notebooks and code, support each one of those PDF files. So, if you're working on the Lab 1 classification system, this is how you'll go into the notebooks. Remember when I said in Databricks, you would import that file? This is what you're going to import when you bring it in, one of the two of these, depending on which one is your preference. You don't need both. If you're a Scala person, you go with Scala. If you go with Python, go with Python. You notice there's no R, not knocking R. All of the data that supports all of our demos is then in the data folder as well. So you have everything that you would need to get off the ground, to learn this, to do the homework yourself, as well as just a really good explanation as what you're doing as you go through each step. So again, go out and sign up for one of the free Databricks. I mean, neither one of us work on the Databricks team. We just use it and are enthusiasts about it. And so we're not telling you this because we're going to get some sort of like checkbox like, yay, you're using Databricks. No, I mean, you could use Databricks in AWS, as I believe somebody said. You can use Databricks wherever. You can use Databricks locally. If you've got your own local compute cluster that you're using Databricks on, using one of the free environments that they've set up for you. So wherever you use Databricks, these labs will support any of those environments. And then lastly, there's some other examples here, sorry, just for fun. So if you're, since no one's into sports, they won't care. But there's some European soccer predicting out here as well, so more of the FIFA. And then if those of you who wanted help with administration of Databricks, more in that DevOps vein, there is an archive that's been put together for you that automates a lot of the user creation, security management, how you set up your security protocols. While Azure Active Directory is managing a lot of it, there are other row-level security concerns you may have, and this administration archive walks you through that. And then for those of you who've used Spark, you know what user-defined functions are. And so Pandas UDF is fairly new. So there is I put together a notebook of all of the common use cases for these UDFs as well. So a lot of these are just things we've learned along the way that you're not going to really find Googling it. And so we hope that it'll provide you a lot of help, as you're ramping up or learning Azure Databricks.
All right, so now we're going to open it up for the Q&A, and if you do have a question, go ahead and come to one of the mics, and we've allowed just over 10 minutes, 15 minutes for the Q&A. And then I'm also going to move to this last one. We encourage you to continue your journey, and then also, I believe there's a feedback slide, yes. So if you enjoyed this session and you want more sessions like this, please leave us positive feedback.
And if you didn't like it and hated it, you can remark that it's 319 or something else's session. So are there any questions? I mean, those of you who are using Databricks or not?
To the mic. Can you go to the mic?
Can you go to the mic? Thanks.
I just had a general question about machine learning. So is that fine? Okay, so I just, there's some stuff like you have like video editing and you can edit a wireframe to make certain movements or like a president or something doing something or whatever or something like that. Is there any way to use machine learning to detect that? Because it's getting kind of hard to detect that as a human or something. to maybe detect like, oh, this is a machine-generated video type of thing?
Absolutely. So something called cognitive services. It's a service Microsoft has. Every single one of them has free up to like 100,000 runs, so hitting of the API. One of them is the video indexer, and so it does exactly what you're saying. So basically, is how folks like ESPN are grabbing segments and being able to categorize them. So if there's a PGA play and it's amazing, they don't manually go and snip it and store it for future reference when they're going through video casts. So it not only cuts it out, but it also does things like facial recognition of who's in those videos, so then it can apply, other parameters to it. And so it goes through labeling and captioning those videos, so if you need to have captions for closed captioning or other perspectives. But then it has it indexed, so it makes it then very easy to be searchable and referenced to other things within the machine learning space. So yeah, it's called Cognitive Services. Just Google it, and I would highly suggest taking a look at that. It's very, very...
Just being it.
Oh. Did you say Bing? So it's funny, I don't really use Bing for a search engine, but I use it a ton on the back end because a lot that you probably don't realize today is powered by Bing ML APIs. So if you're a gamer, all of the search that happens in Xbox, if you are even down to the Apple Store, and a lot of those searches are all behind the scenes are Bing APIs that are happening in recommending and serving up content for you. So when this example I showed you in deep learning that is taking sound and bringing it together with image recognition, behind the scenes is using Bing Search API components to be able to reference out like the documentation about that part and so forth. So it's funny, that's when she said Bing.
This is a remedial question. I apologize. I'm a UX designer.
No. No, you're fine.
So I want to first clarify, Databricks is basically an application or a platform that pulls together machine learning so that you can go through different models, test them, and then scale them out and send them out. Is that what Databricks is? It's really a platform?
It's an abstraction of Spark in its pure form. So Databricks was created by the creators of Spark as a way to make it easier to bring together these processes. One of them, or these APIs, is machine learning. But then there's also streaming, there's the batch process, the data pipeline, there's different components. Diana, if you'll go to the slide above that one, where it says Apache Spark. So yeah,
Okay, hold on, it's not showing yet.
So basically it brings together all of the different computation types you have, whether it's interactive querying, whether it's batch ingestion, streaming ingestion, machine learning.
Okay, then my second
Sorry, I'm
question,
trying to
sorry.
update
No,
this
you're
to the
fine.
slide.
Second question is, so I've been to some of the other sessions, and they're very low-code kind of cognitive services and that kind of
Yep.
stuff. In order to fully utilize those things, do I need Databricks to bring it in there? Databricks seems like Python and R. I'm not familiar with that. Can I still take some of that low-code stuff and put it into Databricks?
You can. That's what I was going to say. Is while you don't need Databricks, it's not a mandatory requirement. What you're going to find is as you're doing things with those cognitive services that make it very low code, no code, or even down to some of the auto ML. I don't know if any of you have seen that, where it's a very graphical UI interface that does all of the machine learning for you, spits out the model that's best. That's great. At a point, you're going to hit that I now have a really big data set, or I now want to bring together structured from my relational data warehouse with this unstructured set of text. So you start to get into this need to bring in other sets, and that's where you usually have the discussion of, well, what columns do we eliminate? And that's where Databricks becomes really helpful. So you don't lose all the work you've done in the low-code world, you just reference it within your notebook libraries, and that makes it very easy. You can point it out to, hey, I did this in that AutoML UI space, I'm going to reference it in my notebook, and therefore I get all my results set back in the same Databricks notebook as now I'm doing with my big data processing. I'm going to reference my cognitive services, same thing. You just basically need to set up and have your key, your cognitive services name, and that's it. It's all then integrated together. And that goes back to the whole having that common platform in Azure makes that very easy, and or then referencing third-party libraries like TensorFlow, which is outside the Azure landscape but can be easily utilized within.
Thank you.
Yeah, no problem. Thank you for the question.
So I have a question. You mentioned that you weigh the human factors while making the model. So how do you weigh it, and what are the factors you consider? So for example, I work for a construction software company. So I was thinking on the same route where we can design a machine learning algorithm, but we have the biggest factor is humans and machines. So I wanted to understand more on that. So.
Yeah, no, absolutely. So, in this space with the basketball, I had what does my husband say it should be? And that had a weight, very skewed and biased. It had, like, my father-in-law's opinion. It still mattered. I took into account all of the experts. So if 72 ESPN experts said it was this, I gave that a weight. And you can imagine, with my bias and all, I would weight the experts over others. So the way that I created weights was to just basically start with a set of weights and run the model, and then look at performance. And those are the parameters that you can hyper-tune as you're running through retraining if you get a totally terrible set. I mean, I'm building something on the Kentucky Derby for one of my friends in the audience, and the first pass of it was horrible. It was 40% accurate. And those are the kind of, domain discussions you want to have with, your business or with your business experts to then say, what didn't I capture right? Maybe I applied too much weight to this. But you have to start with something. So you use your best case logical judgment on setting those weights, and then you parameterize and tune them going from there. And so yeah, when you're waiting for the intelligent factor, I think that's an interesting topic that not a lot of people cover in machine learning at depth, because you can process and make something very consistent in terms of a machine. But when you have a human and a human involved in that process, you can only do the best case. People are not automatons yet. And so they're going to each do something differently. I mean, I even measured how I made toast every day. I did this, sadly, for like 60 days. And I didn't even do it the same every day, and it's me. So imagine you have multiple people in your process. You would want to weight that accordingly so that information that's coming from those human process, which is fraught with errors or potential for errors, gets weighted accordingly and shows up in the data that way.
Can you set it to where the model's continually running, and as new data is inputted, it keeps updating the likelihood of an event?
That's a great question, because when I hear that, in the beginning I would have said, yes, you want it running always in Databricks, and then I did that myself, and my boss came to me one day like, you've cost us internally a lot of money, because it costs a lot of money to keep anything running forever on a compute source. So what you do instead is you run out your training set, and this is where that Databricks Delta call out I made about when things change becomes really relevant, because you have your original training set, maybe you have some new modifications. Those become almost that change data capture stored in a much smaller table. So A, the training time is much faster when you need to retrain. You can then bridge them together very fast. And then you have that, you don't have to rewrite and rerun to do things like upserts or appends, to that original data set. It's just some of the ways that Databricks works with change data capture. So no, you would want to create a feedback loop that basically says, here's my pure play model end to end, from point of when I've created it to deployment. Typically, people are deploying these as images, so you can think of it like a Docker image. So they've got it all bundled together with their libraries, their training set, it's been trained. Now when things change, that change file is just part of that feedback loop that gets triggered, whatever that trigger may be. It could be event-based, there's new columns. Maybe you refresh it on an X time period so that if there is an important feature that is a new column, you want to pick that up as soon as possible. But whatever that is, it's the same feedback loop, just with a training cycle that occurs that's trigger-based, picked up, and then you're just running it on that new set. You're running it on whatever that new set is, bridging it into your old training set so that you're not, A, continually running stuff, and B, you're really optimizing your compute cost. Does that make sense?
It does. So if we had a nurse filling out a form, and it's just filling in fields in a database, to every time a new data value comes in, we say, oh, it's this likely the person's going to end up back in the hospital. Mm-hmm. Running it continually like that will be crazy expensive.
Oh, yeah.
You're better off when the form is done, you run the algorithm.
Right, and so I've done a lot of work with forms processing and ML from a healthcare perspective. And so what you'd want to do is you'd want to take out, from this point in time, here's all the entries that have been made to these forms. So this is going to become my training set. We're going to find out which one of them point to outcomes. So maybe if they answer this question, we know it leads to this outcome, and that's what we're trying to optimize or make better. And so you know what your feature is or your X's are from the form. You know what you were trying to predict or what your predictor is. So you can basically structure it that way. Now, as the form changes, the values don't matter. You've trained it on that set. What matters is as new questions come onto that form. Now you're capturing new pieces of data, so new drop-downs, those types of things. That is when you'd want to trigger that event for your particular use case.
Thank you.
Yeah.
I know on Bing they have predictions for NFL games and for the FIFA World Cup games, and they tend to be heavily influenced by the wisdom of the crowd, right?
Yep.
aka betting odds.
Yep.
Did you find that impacted much on your and
100%.
March Madness?
Yeah, so I actually, that's how I came up with things like how did I rate ELO and Nate Silver's score? How did I rate MASI for basketball? So any of the traditional sources of folks that are the experts in this space, I weighted them differently based on their performance over a long period of time. And I had to make the judgment on, am I judging them on this season or for the longevity that they've been making judgments? I mean, if someone judged me on year 1, they'd be like, you're terrible, I'm never listening to what you have to say. But by year 7, the accuracy grew. So I made a curve that said weight them as their accuracy changes over time and weight them more importantly. But yeah, so I mean, there's a lot of logic that goes into how I'm looking at it. And that's one of the best parts of machine learning is you start with a set. Here's all your data sources. You run it, you get your result set. As they are good or bad being relative, you have to make a judgment call on how much more you want to bring in, because believe me, I can sit and analyze something to death. I can no, it's not good enough. I want that 1% gain, on my model. And at the end of the day, what is good for your vertical space? If we're talking healthcare and cancer, just, we're going to find cancer in your x-rays, well, that needs to be like, 99.99999% accurate. But if we're talking about picking out the right part, well, it's still important to be fairly accurate, but you have a lot more leeway there. So yeah, that I did find that the data was very much skewed by that, and you should be cognizant of that as you're planning out your own models. But I do have call-outs about all of that in the notebooks that I have. I don't know which one of you
The
got
very
there
back
first.
person.
Okay.
Thank you. Hi. Thanks for a really crunchy talk, by the way, even though it's quite above my grade right now. Can you speak a bit on that deep learning through sound example you gave? Because that's really interesting. Because it's not exploiting some well-known data set
Right.
exclusively. So what did it take to get that operational and useful? Did you have to, how much data set did you need? Did you have to engage subject matter experts to do the training? How much load went into making that functional?
A lot. And to convince somebody to go down that path when they haven't been doing it is hard. But what I did is, first, MIT put together a corpus of training data of sounds environmentally. So that was a great starting point, because in that, I was able to capture things that were machine-based, engine-based, to at least give it a flavor of what it should sound like. But then it required a lot of on the ground to say, let's go out into the field and make some of these sounds. Now, once I got those sounds, maybe 10 samples per part, let's just say, and we were using a very limited sets of parts, I took it and created the larger training set from that by doing things like Gaussian blur, which sort of smooths it out. I was taking out all the environmental noise. I took out any of the pauses. So I could create what looked like very similar sign patterns in terms of the audio, the spectrum. And then as much as you could normalize it, that then became my set. I took what they provided, augmented it with what I cleansed, and then I had a much larger set to use. So that's how it all started. Now, I have a lot of details on the audio because I know, to me, it's also very interesting because you can use this deep learning to do things like become a composer, create your own music. You can take sounds and songs you like and have machine learning actually pair them together to create altogether new sounds. For me, it was more in a business, practical sense, but there's a whole bunch of use cases for doing the audio signal processing.
Thank you very much.
Yeah.
I guess I have a follow-up question to that. It's a similar one in that I'm developing a health device where you breathe into a bag and we look at a person's breast sample.
Yeah.
We're also collecting location, age, gender data as well. We're not using machine learning yet, but I'm curious how much data, at what threshold do you have where you have enough data to actually have a useful machine learning data set to go through this stuff?
So we like to say to have 30 at a minimum per class, and by class, that becomes your category, if you will. So, if I have bolts here and nuts here and, modules here, those are 3 classes, so you'd want 30 at a minimum. 50 is an ideal number of samples to have. But the great thing is, whether it's images or sounds, you can take a very small set and augment them and use machine learning to change them around, make them black and white, angle them, rotate them, zoom them in, zoom them out, crop them so they don't have background. All of that can be done via machine learning automated-wise, so that what is 2 pictures now becomes 30 pictures, and you then have enough sample to be able to run the ML model, which is great.
Cool, great job, by the way.
Thank
you so very much. So, how do you deal with curve fitting, particularly with model drift, right? I mean, you can, and not by curve fitting, I mean overfitting, right?
Yeah. So it's always great to have accuracy come up very high, because you're like, great, I built the best model in the world. But more than likely, it's because you overfit the model, meaning You hyperparameterized, you tuned it in such a perfect way in your train set, and the test set that you're using to test it is too similar. You didn't have enough of testing data of real world that the model can account for. So it's going to make everything look like it's modeling great until you get out there and you're actually running through your samples and testing it in a real world scenario, and then you have terrible performance. Your model accuracy is in the pits. And this is why it's really important to look at other evaluation metrics other than what you might believe is the best metrics to look at. So while I may look at accuracy, I then look at what my mean squared error is. So how much error rate is the model having in associating the right, buckets? And that's why I showed you the confusion matrix. Because while it may have shown a very high degree of ability to categorize correctly, the buckets that it got wrong are the ones I want to tune and fix. I want to find out why it got it wrong, because that's what you need to work on in order to have a properly fit model. So it's always important to look at the fit, look at your model curve. If you get high accuracy out of the gate, you're probably overfitting it. And you're going to want to go back and take a look at how much data am I using to test. If you're using 80% to train on and 20% to test, you may want to then have a test set and an evaluation set, so you can further test basically the test. So there's a couple of ways to handle it, but that's at least how I would handle it.
So we're at time
We're
now.
at time now, but I can talk to you, after the
If
fact.
you have additional questions, just come up to the stage and we'll be here.
Thank you guys so much for your
Thank
participation.
you so much.
Really appreciate
And again, please fill out an evaluation for us. We appreciate your feedback.